Okay, my friends, we're going to look at a similar example here, but tied to the context of the problems we've been looking at in the project. So we're going to establish why the probability of selecting an African American from this group of apartment renters is about 20%. But I want to tie that into the meaning of what 20% means. Kind of like we did back in 105 when we knew, quote unquote, knew that the chance of rolling any given number on a six-sided die was about 17%. And then I asked you, well, what does that mean? Well, we're going to see that here. Now, what I've done is, speaking of dice, I've coded Excel to roll a 212-sided die. Now, 212 sides because there are 212 people in this apartment complex. And I want folks to be chosen at random, which means everybody has the same chance of being chosen. So that person is being chosen right here by the command ran between. I put ran between 1, 212. Every time I re-randomize, I get a new person. Currently, I'm at person number 4. Now, you might look up here and notice that the Caucasian section A quadrant is being highlighted. That's because I made Excel decide if the random number is between 1 and 87, then you highlight that cell right there. If the number is bigger than 87 but less than 170, you're going to highlight Caucasian section B. And similarly, I've got Excel coded to highlight African American section A and African American section B based on the results of that random number. So right now, it has randomly selected someone, and that someone is not African American. So that data is being kept track of down here. So far, we've had one trial. No African Americans chosen randomly, so therefore there's a 0% chance right now of selecting an African American. But of course, that's one trial. I think we should select some more trials. I just did a second trial, and once again, I got somebody from section A that's Caucasian, so still at a 0% chance. I'm going to select it again. Aha! Now I've got one, because I selected somebody from section B who's African American. 1 out of 3 is 33%, and I think you know where this is going to head. I'm going to hold down F9. And I'm going to let this thing just do its thing, which is basically randomly selecting over and over again, over and over. Now, what's kind of fun about this one versus the other one is, do you see how much more the Caucasian column is blue than the African American column? Well, that should make perfect sense. I hope it makes perfect sense to you, because there are more Caucasians in this apartment complex than there are African Americans. So if I'm randomly selecting folks, I should be getting more Caucasian selections than African American selections. I am getting African American selections, but the question is how often? And as I've been talking, you're seeing it down there. And very, very similar to the guessing at the multiple choice questions on that test from the last example, you're seeing that number stabilize right around 20%. Now, why is it stabilizing right around 20%? Well, if I'm randomly selecting from this population of people, 20% of the total are African American. That means if I'm truly randomly selecting, I should be getting about that 20%. Or in this case, 397 selections out of 1,990. So the reason I did these two videos is just to drive home the point. Yes, those percentages can come from data, like we pull them off the table. But they can also come from observation, which, as we're going to see as we move through the course, observation is often the only way to get this data. All right, more to come, but for right now, let's keep moving through the project.